Nature is filled with forms that are fractal-like. They are not true mathematical fractals, but they do have some things in common. For example, consider a tree. Small branches look like big branches, which look similar to the entire tree. The fractal characteristic, where small parts look like big parts, is called self-similarity.
There was a period in my life when the idea that self-similarity is so widely present in nature, and in particular in plants, that I was looking for it almost everywhere.
To Dr. P, it seems like nature relies on fractal geometry. And to capture the fractal nature of plants, he turns to a mathematical tool called an L system. An L system is simply a set of repeatable rules that can be used to create structures, like the branches of a tree. For example, an L system might state that if we start with the top of a branch, this portion will always form 2 new branches and 3 new tops. If we repeat this simple rule, a complex branching structure is formed. To model a lilac on a computer, Dr. P first creates a simple L system. Next, he takes careful measurements of the branching structure. With this information, Dr. P refines his L system to closer reflect reality. Once the branching structure is complete, he adds the final touch by creating self-similar flower blossoms.
It is very exciting to see that structures which we used to think of as very complex turn out to be very simple in principle. A plant is repeating the same thing over and over again, but since it is doing it in so many places, the plant winds up with a structure which looks very complex to us. But it is just intricate.
Today, mathematical equations are producing a striking new view of the natural world. And this new view is suggesting a rather provocative idea. Much of the complexity we see in the natural world may be the result of some very simple rules.
Creativity is the essence of mathematics. Mathematics is not playing with numbers and doing accounting. Mathematics is dealing with ideas in a creative yet very precise way.
I've been studying in tropical rainforests for 20 years. It's so beautiful. The rainforest is full of life. Everywhere you turn, there's some creature, plant, or animal, and so many different kinds, you'll never see them all. It's really a vast unknown.
In 1989, Tom Ray moved from the tropics to begin his spectacular experiment. What he intended to do was create a virtual rainforest. One that he had built from scratch using mathematics. Ray built his artificial world inside a computer. He imagined that the landscape would be filled with creatures he called digital organisms. Like real living things, digital organisms could actually reproduce offspring. To build his creatures, Ray relied on a powerful mathematical tool called an algorithm. An algorithm is like a recipe. It's a set of instructions. Inside a special computer, Ray's creatures, seen here in green, would have to follow an algorithm in order to reproduce. First, the creature would have to measure its size. Second, it would have to find space in the computer exactly that size. Only then would it be able to reproduce. Some offspring, however, would be different than their parents. Occasionally, there would be mutations, signified here by a lightning bolt.